Today we are looking at section 7.2, properties of a parallelogram. So our essential question is, what are the properties of a parallelogram? First, we define a parallelogram. Right? Parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay. And remember, when we're marking parallel, we use arrows. So when we see a parallelogram drawn out, if we want to mark it as a parallelogram, we would mark it something like that. Okay, and our symbol for parallelogram, if we're writing something out, is just basically a parallelogram without the arrows there. So if we're saying parallelogram, that would be our symbol for parallelogram, right? Similar to the drawing the trine was a symbol for trine. Okay, so we have a couple theorems of things that we know if we have a parallelogram. We have 4 different theorems. So, first one, parallelogram opposite sides theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So we have parallelogram PQRS. So since we know that is a parallelogram, I know PQ is congruent to RS, and I know QR is congruent to PS. Okay. One of the things the book will ask, and the questions will ask, is how do we know this? So instead of memorizing all the theorems and their names, like parallelogram opposite sides theorem, we're just going to say what we see. So here, right, we're saying opposite sides, my congruent would be my reason if we were using this, and they're asking me, why do I know PQ is congruent to RS? Then we have the parallelogram opposite angles theorem, right? The opposite angle, so if a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay. So in PQRS, angle P is opposite angle R, so those are congruent. And angle Q is opposite angle S, so those are congruent. And our reasoning here would be opposite angles congruent. Okay, and in our first example, they're asking us to solve for x and y. So pay attention to what they're giving you and what you know about it. Here, we have x plus 6 and 13 as sides, 68 and y as angles, and both of those are opposite. So for my x, I'm just going to go x plus 6 equals 13. Subtract 6 from both sides, x is equal to 7. Okay. And if they ask me how do I know that, my reason would be opposite sides are congruent. Y, opposite angle is 68, so y is just 68. And again, my reason for that would be opposite angles congruent. Then flipping over, going to the next page. Right. Parallelogram consecutive angles theorem. Right. So if a If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Remember, supplementary means they add up to 180. So what they say here is if PQRS is a parallelogram, then X plus Y equals 180. All right? But I have different things that I could use that with. So P plus Q is 180, Q plus R is 180, R plus S is 180, and S plus P is 180. That makes sense if you think about them being equal. The ones that are equal and the ones that are not equal, one pair of those adds up to 180. So our second example, right? They give us our sides and they give us different things for angles. We're looking for X, Y, and Z here. So X, we're still using opposite sides congruent. So I have 37 equals 2X minus 3. So 34 is equal to 2X. And X is equal to 17. We didn't talk about our reason up here. This would be consecutive angles congruent, or consecutive angles supplementary. So consecutive angles are supplementary would be our reason there. So when I'm looking at the next one, right, we have 123 Z and Y. Y is just equal to 123, all right, because our opposite angles are congruent. And then Z plus 123 equals 180. All right, so our Z is going to be 57. Then we have our parallelogram diagonals theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember, bisects means cuts in half. So I have diagonals of QS and PR. Each of those cuts the other in half. So QM is congruent to SM, and PM is congruent to RM. Right? The diagonals, in most cases, will not be equal. We'll look at special parallelograms later where they are, but in most cases, QS and PR are not equal. The parts that's on the same line are equal. So in example 3, right, they give us some different things and ask for parts. So the first thing they ask us for is NM. Right? MN is on the same line as KN. It's part of the diagonal, so it's bisected. So NM is 2. Right? And then that would make KM, the whole line, 4. Right? And then they ask us for JML. Right? So I trace that JML. I'm looking for that whole angle. The angle here is 110. So I do 180 minus 110. And I get that is 70. And then they ask me for angle KML. If I know this whole thing here is 70 and this is 30, I subtract and get KML is 40. So KML, well, this angle 2, would be right here, right? And then this angle is the whole thing. Turning the page. Again, we're using our diagonals bisect each other theorem. Find the value of the variables. So I have 15, 9, B minus 1, and 5A. The key thing is what you're matching up here. Right? So 15 and 5A are on the same line. That line is bisected. So 15 equals 5a. So a equals 3. And b minus 1 equals 9. So b equals 10. Right. Example 5. Right, what they're really asking us to do here, the way they draw it, you sort of can figure out where it is by counting over. What they want you to see here is because it's bisected, right? We can use things like the midpoint formula, right? So if I look here, they're asking me to find z. I could do this with either diagonal, right? I'm going to do it with w and y. So I know w is at 2, 6. And I know y is at 5, 0. Right? So I can use the midpoint formula. Right? So remember, midpoint formula, I add my x's and divide by 2. I add my y's and divide by 2. So I have 2 plus 5 over 2 and 6 plus 0 over 2, and that point, then I have 7 over 2 and 6 over 2. 7 over 2 you could leave as 7 over 2 if you want, that is fine, or you can write it out as 3.5 or 3.5, whichever you're most comfortable with, and this is 3, so that is my point for z. And then the last one, finding the remaining vertex. Right, so they give us D is 0, 2. They give us E is -1, 5. And they give us G is 4, 0. Right. Now, part of this is how you connect them on where your fourth point is. Right. So start looking at where you're drawing your lines here. So I want to draw them here. And one of the things to remember with these is lines that are parallel have the same slope. Okay, so I can look at the slope of these lines. Right. So if I look here, I come over 1 and up 1, 2, 3. So if I start here and come over 1 and up 1, 2, and come up, 1, 2, 3, that point would make that parallel. All right, so then I have that at F is at 3, 3. Okay, if I connected my lines differently, I have a point that is a slightly different part. So there's actually a couple answers here, but there's very limited answers. So you can have more than one. Right, that will end our 7-2.